So our next speaker is Alanna Pierias, and she'll be talking about tracking functional recovery following concussion using cognitive motor integration.
Okay. Hello, thank you for having me here today. My name is Alanna Pierias, and I am a master's student under the supervision of Dr. Lauren Sergio at York University. So as already said, I'm going to be talking about tracking functional recovery following concussion using cognitive motor integration. So currently, majority of standards for managing concussion are cognitive and physical rest. And majority of athletic trainers in the United States are using computerized neurocognitive tests for baseline and follow-up when assessing concussion. As well, we have began to develop the protocols to a multifaceted approach. So this includes balance, cognitive and mental status, neuropsychological performance, and self-reported symptoms. However, the tests currently being used test these multiple facets sequentially, so separately. We all know that sport requires thinking and moving at the same time. So why do the current standards test these aspects sequentially? We believe that testing recovery indicators sequentially may result in inappropriate concussion management, and this includes things like failure to identify the initial presence of concussion, premature post-concussion return to participation, and this can elevate the risk for repeat concussion, and the potential for second impact syndrome and death. So just quickly, I'm going to talk about Ms. Rowan Stringer, who is a very poignant example of why we need to continue to improve the return to play protocols. So for the safety of those recovering from concussion, it makes sense to measure the integration of thinking and moving, or cognitive motor integration. For our case, we looked at standard, which is a direct interaction. So your visual stimulus is also the target of your action, for example, shaking hands or picking up a cup of coffee. And we also looked at non-standard. So this is where the gaze and reach are spatially incongruent. And one way which this occurs is dissociation between the planes and reach of vision. So for example, using a computer, your plane of vision is vertical and your plane of movement is horizontal. As well, for us, we did a rotated visual feedback of 180 degrees. So, for example, if you were to hold this the wrong way, pressing the opposite button would take your slides backwards instead of forwards. So, some of our previous findings from our lab, we found performance deficits when using cognitive motor integration, which the task I will speak on in a moment. In collegiate level athletes, elite level athletes, adolescents, and children with a previous history of concussion when compared with control athletes without a previous history of concussion. And they found differences in reaction time, movement time, and precision measures. However, these studies were done cross-sectionally, so while they are a good indication that cognitive motor integration is a predictor of these behaviors with concussion, the purpose of my research at this point is to extend that the use of this cognitive motor integration task, which does require a non-standard visual motor transformation, may allow for a more objective and sensitive measure of the individual's athletes following recovery from concussion, and I'm doing this on a longitudinal basis. So I hypothesized that the athletes who are following the current return to play protocols will not return to their own pre-concussion baseline measures at the state that they are returned to play based on the current standards. So my participants include varsity level athletes, and I have taken data from concussed versus controls, but today I'm just speaking on the concussed group. And they're measured at time points aligned with the return to play protocol on our cognitive motor integration task. So we are comparing their baseline measures, so beginning of season, to their when they're returned to step 1 of the return to play protocol. These are the measures that we looked at. So our kinematic outcome measures include reaction time, movement time, path length, peak velocity, accuracy, and precision. And a trial was considered incorrect if the reaction time or movement time was too long, they moved in the wrong direction of the target initially, or they missed the target altogether. So now I'll talk about the task, and hopefully what I just said will become a little bit more clear. So we had 2 visuomotor transformations, a direct and feedback reversal and plane dissociated, which is a mouthful, so non-standard. So our standard condition, the eyes and hands are moving on the same screen, and the individual is moving directly to the target, which appears. I'll give you an example of that now. So we're using a touchscreen tablet. We have a center target appear, and the participant moves the cursor to the center of the target. It will turn green, at which point a peripheral target, either up, down, left, or right, will appear, and the participant slides their hand to the target as quickly and as accurately as possible. They hold there until the center target reappears, and then they slide back, and this is the standard condition. Then we have our non-standard condition. So in this case, they are viewing their target on a different plane than their hand movement is occurring, and the feedback is rotated 180 degrees. So if a target appears to the left, the participant is instructed that they will need to move their hand to the right in order to get the cursor to go to the left. And here's an example of that. So you can see their vision would be on the vertical screen, and their movement is on the horizontal screen. They slide to the center of the target, peripheral target appears, move, center target reappears, move back. This is an individual case taken out of our data. So this is their baseline measurement on the non-standard condition. So all of the images that I'm going to show over the next couple of slides are the non-standard condition. So this is how they performed on the non-standard condition at baseline, and this is how they performed on the non-standard condition at return to play. So the purple circles are the targets, the peripheral targets. The blue dots are their final endpoints of their movement. The red dots are where they began the movement, and the green lines are their trajectory. So as you can see, this individual was performing extremely well at her baseline levels, and when she was cleared to return to play, she was performing much evidently worse. This is another individual, so this is the baseline measure. Again, you notice that their trajectories are not quite as accurate as the previous individual, but this is their return to play. So my question is, would you return this individual to the field or to the rink? For our preliminary results, we did notice a learning effect. So for the trials that the individuals are performing correctly, they are performing them seemingly better, so they have faster reaction times, faster initial movements, higher peak velocity, and a decreased variable error. However, we see a very significant increase in the number of failed trials. And this is our group data here. So in conclusion, at return to play, our athletes are having a significantly higher amount of incorrect trials despite showing improved performance on timing and final accuracy variables. But importantly, these athletes have been cleared to return to play. We believe that testing performance on multiple domains concurrently, so in particular cognitive motor integration, may provide a simple and more sensitive assessment, reducing vulnerability to further concussion. So some references, thanks to my lab and my supervisor, Dr. Lauren Sergio. And
that was, thank you for that talk. And according to the clock here, you have won an award for the briefest talk, so very impressive. You have time. We have time for several questions.
oh my,
You're interested.
maybe I should have spoke slower.
I'm going to ask a question. So it's so nice to see this sensitive measure for the presence of concussion symptoms that's showing up after conventional measures are saying it's safe for someone to return to play. And you probably know the work of Brad McFadden's lab, and it seems that these more complicated tasks are what reveal the presence of persisting symptoms. Do you have any plans to develop normative data for this so that it actually can be used clinically?
Yes, we are definitely working in that direction. We have currently used this software with I think over 600 athletes on a very wide age range, and also it's being used in Alzheimer's and dementia as well. So that's the hope.
Right.